All right. Advent of Code is finally here. 2023, day 1. Let's dig into it. Day 1, Trebuchet. Oh no. Something is wrong with global snow production, and you've been selected to take a look. The elves have given you a map. On it, they've used stars to mark the top 50 locations that are likely to be having problems. All right, that's where the stars come from. You've been doing this long enough to know that to restore snow operations, you'll need to check all 50 stars by December the 25th. Collect stars by solving puzzles. All right. Yes. You try to ask why they can't just use a weather machine. What's that a link to? Advent of Code 2015, day 1. Ha! There's a throwback. Not powerful enough. And where they're even sending you? The sky. And why your map looks mostly blank. You sure ask a lot of questions. And hang on, did you just say the sky? Of course. Where do you think the snow comes from? When you realize the elves are already loading you into a trebuchet, please hold still when you strap you in. Okay, it's just a link to Wikipedia. Very good. As they're making the final adjustments, they discover that their calibration document, your puzzle input, has been amended by a very young elf who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the values in the document. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. All right, this is a bit complex, a bit more complex than the usual parse the numbers and manipulate them somehow. Trebuchet. In this example, the calibration, these 4 values are 12, 38, 15, and 77. But, first digit and last digit, and this 7 here counts as the first and last digit. All right, we can do that. We can definitely do that. Let me get my puzzle input. Get input 2023, day 1. All right, so we have 1,000 lines, so that's not too bad. That'll go pretty quickly. So, I see. Interesting here. We got the number 2 in there. 7 in there. That might come into play. Part 2. Why else would they be in here? There's another 7. There's a 5. There's a 1. Okay. All right. Enough reading the input. Let's take a look at... let's see if I do this and go C2301. That's just the input. So I haven't created the file yet. I have not. Look at that. Yeah, so I have to say what? Mod AOC 2023-01. I forget how I do it all now. And do that. Create the module. 2301. And unfortunately, I have to change this here. But then I need to put it into this vector. AOC 2023-01, and then it was AOC 2023-01. Oh, I forgot how it all works now. All right, this is my stumbling block, right? Let's take a look at AOC 2022, source main. Right, I have the mods. Oh, then I have the use statement, right? And use AOC 2023-01 star. Like that. And then it's just, I create the day like this. Okay. I'm going to have to figure out a different way to do this. And then we just add it here. And it's mutable. Like that. Mut day 01. Right? And now if I hit run over here. Oh, look at that. It worked. Okay. I'm more excited about that working. All right, let's go to this. And parsing is easy. We're just going to read a bunch of lines. String. Right. Self lines equals AOC lib. Read lines. Input 228301.text. And then we'll just output the number of lines, self lines len, and that should be 1,000. Perfect. Okay, so now we just need to loop over all the strings. I think this is going to be relatively easy for L in self lines. I'll call it line. And then we just look for the first digit and the last digit. I mean, how hard is this, right? Let nums, let's say, is equal to line dot chars dot filter ch, and where ch is greater than or equal to 0. Let's see, these are characters, right? So that and ch is less than or equal to 9. And then collect into a vec. Right, and we get the list of characters. Oh, what we can do is map them into numbers, right? We could say map ch as u8 minus b of 0, right? There we go. And Tommy reminds me, is ASCII digit exists. Thank you, Tommy. I'm doing it the hard way. Oop. How come I can't do code completion here? ch is a character, right? All right, so now nums should be u8s, so we just need the first one and the last one. Let first is equal nums iter nth 0 unwrap. And then last is, instead of nth, we're going to say last unwrap, right? And these should be u8, references to u8s. Let's deref them. And now we just need to turn it into two-digit number. And add it up, right? So let's say total. And we'll say total plus equals first as I32 times 10 plus last as I32. And then total. Does that seem straightforward? Astrothexer, thank you. Hello, sorry. And I don't know why I said thank you. 54,916. What do you think? Hey, that's the right answer. All right, that was nice. Git status. Git add source. Cargo lock. There we go. Git commit dash m 2023 day 1 part 1. There we go. All right. That was simple enough. It took me how long? I started 5 minutes after, and now it's 14 minutes after. Well, 14 minutes into the stream. Not bad. For me, not bad to do it in 11 minutes. Just out of curiosity, I'm going to take a look here to see how fast people did it. Where is it? Is it this way? No. I forget how to, here's the global leaderboard, but, oh, I see, per day. There it is. All right. So it took 2 minutes and 24 seconds for a Bobo Quack to do both parts. And 12 seconds for WordOz to do part 1. 12 seconds. If they streamed that, I would love to see that stream. 12 seconds. All right. Well, anyway, we got it working. It took us slightly longer than 12 seconds. That's just amazing. I would love to see how they stream. I'd love to see the stream of how they did that in 12 seconds. All right. Part 2. Your calculation isn't quite right. It looks like some of the digits are actually spelled out with us. So yeah, we did notice that. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 also count as valid digits. Equipped with this new information, you now need to find the real first and last digit. Okay. Let me think about this for a second. And now I understand Rondev saying this is more complicated than the average day 1 part 2, shall we say. I know how to do it. The obvious solution, I guess, would be to use a try. I'm not going to write a try. The way the Aho-Corasick algorithm works, right? To find all matches. And then we just find the first and last match. But I think we can we'll just brute force it. I think brute force is the appropriate approach. Astrofixer. Sorry, I don't know how to say the last part of that name, but thank you for the follow. Welcome. Let's create the list of words. Let's call it nums. Oh, I called this nums up here. Well, that's all right. Let's do 1, 2, 3, 4, 5, 6, 7, 8, and 9. They didn't mention 0 in there. Yeah, 1 through 9. Huh. Are there any zeros in the input? Grep 0 input. There are no zeros in the input. Interesting. The X is a substitute for O. Astrothor. Okay, I will have to remember that. I will endeavor to remember that. And then we'll do the same thing here. Total equals 0, and we'll just output the total. All right. So we need to find the first entry. If there's no 0, we can kind of cheat, right? I'm going to do this. Right, and I'll just find the first thing and then divide to get the actual index. Is this cheating, or is this an acceptable brute force method? 7. Oops, I missed 8. There we go. Okay. So now what we'll do is I'll just look from the start for line in self lines. I'm going to repeat this code for going forwards and going backwards. So, let's say for I in 0 dot dot line len. And then we'll say for num in nums iter. And we'll figure this out. If I plus num len is greater than line len, then we'll continue. Right? If it doesn't fit, right? If we're near the end, we don't want to start looking for 7 here. Astrothor says, what does ampersand mean in Rust? And Tommy says, get a reference to. Yeah, so this is referencing the lines list. If I did it without the thing, it would still work, right? But then it would consume, quote unquote, consume all of the lines in this vector. And I wouldn't be able to reference them ever again, or later on in the code. But by taking a reference to each one as I iterate over them, then I can use them again. So it's the same thing as doing, just saying self lines iter, like that. It's just shorthand. Okay, so now we're going to compare to see if this is equal to the string we found. We do need the index in order to figure out which one we found. So how do we do this part? We want to say if line of I dot dot num len, I plus num len, is equal to num. We might have to deref things or whatever. If we found a match, then we're going to say we found the first index. Let first equals none. So we'll say it's first is equal to sum index divided by 2, right? Because this will be 0 and 1. It'll be 1 plus index divided by 2. 0 and 1 will index divided by 2 will be 0, right? And then 2 and 3 will end up being 1. And so then this will get us to the actual digit we need. Hopefully everybody agrees with that. I think this is all we need to do. Let's find out. Println L goes to first. And let's see what comes out. Oops, L line. I meant line. I don't know why I said L. Can't compare stir with star amper stir. Yeah, but I don't think that would work either. Option usize. All right, let's see what happens. There's a 3, right? Oh, I found a 4. It should have found 9. Okay, we're already messing up. Oh, I didn't break because I'm an idiot. Break out. That's why it found the last one. There we go. Now it found 9. It found 8. It found 7. It found 2. Good. Found 1. It found 7 here. Hopefully it found the correct 7. I'm looking for one that starts a word number. That's here. Here's 8, right? And it found 8. Okay, so it found it forward. I think now we just repeat the same thing. Actually, what we can do is we can flip this out, right? We can say let sum first equals first, else panic invalid input, right? Or a bug in my code, but I'm going to call it invalid input. And then we do the same exact code for going in reverse. Right? Let last equals none. And then change the first to last. And then we can do this. Right? We say total plus equals. What are these? Those are use sizes. Okay. 10 times first as I32 plus last as I32. How's that? And then we output the total. And that didn't work because we have an unexpected token because I forgot the semicolons over here. 54,728. That's the right answer. Huzzah! I've completed day 1. Let's see what the calendar looks like. Interesting. Very good. This looks like almost like a sawhorse used for construction. But I'm gonna let's take a look. Let's take a look at the Aho-Corasick crate and see how to use it. I've never used it before, but that's the algorithm that you use for this kind of thing. So let's see. How do we use this? We have the patterns, and we have the haystack, and then we say find iter. All right, let's try this. Let's try this. Let's first commit these changes. 2023 day 1 part 2, right? And then we'll just add this crate. Cargo add Aho-Corasick. Oops, did I typo it? C-O-R-A-S-I-C-K. There we go. So now I think the way this would work is we just stick all of these in here and just grab the first and last after we run the find iter. Let's try it. So we know our target number, right, is 54,728. And let's just pull that up here so I don't have to memorize it. 54,728. So it's basically going to replace all of this, right? And what we'll do is say for line in lines. Let's take a look at that example document again. So we have our patterns. That's up here called nums. So all we need to do is say, find iter. Let's just collect those into a matches equals. Oh, we have to build it. I see. Let AC equals Aho-Corasick new nums unwrap. It's an unknown. Oh, because I haven't imported it yet. There we go. Okay. So now let matches equal AC find iter haystack line. And that should give us all of the matches, right? Tommy says your program you saw reflects your C background. Everything is so raw with fors instead of using functional approaches. I try to have a mix of both. I like functional approaches when I can, and I use fors when my brain defaults to that. I could say self lines iter map, right? And then generate all of the thing. The problem is the more complex you get with your functional style, the harder it is to read when you're coming back to it later. Right, because now what I need to do here, well, let me write it with a for loop, and then let's see how complex it'll look with a in functional. So we have the matches. This should be a vector of something. Oh, I got to collect them. Now it's a vector of matches. Okay, and now I see this pattern ID. We have mat pattern, and I think this is the index of the thing we found, right? So this would equate to my index here. So we just need to extract that. So I can say let first maybe equals matches iter nth 0 unwrap pattern question mark, and that's a pattern ID. I wish I could click on that. Structs pattern ID, identifier of a pattern, got private fields. Can I get the value? Oh yeah, I can just say as I32. Okay. Oops. As I32. So that should give me the first index, and then let last equals matches iter last unwrap pattern as I32, right? And that'll give me the last one, and then I can use the same logic we just used. Total equals 10 times first divided by 2 plus last divided by 2. Right, let's see if it comes up with the same answer. 54,728. 51. Sweet. So let's find out what I did wrong. This all looks right. Mahat says, why divided by 2? Because the index is going to be 0 or 1, depending on if it's a 1. And it's going to be 2 and 3 if it's a 2. And it's going to be 4 and 5 if it's a 3. 0, 1, 2, 3, 4. Oh, wait, I got to add 1. That's why. I can just add 1 here. I can just divide by 2 here, and then I can add 1 here. That just takes it to 62. Ah, thank you, Scoops. What a goofy mistake to make. And it's a wrong answer. That's interesting. That's interesting. All right. It's not completely wrong, but it's just enough wrong that's making me annoyed. Let's do this. I'll call this AC first and AC last. Let's blow this stuff away. And then we calculate our own first and last, and let's print out where we mess up. Println L line goes to, if first is not equal to AC first or last is not equal to AC last, then we'll print first, last versus AC first, AC last. Right? And we can find out why that's all wrong. Oop, I left that in. You can convert an I-32 to, this is a I-32, what is this? Oh, is it, okay. Can I do as usize? Does that exist? It does. 33 versus 22. Oh, because I didn't add the 1 here. All right, that's better. 91 versus 92. Why? This is 9. Oh, yeah. Okay, so this is the overlapping situation that, right, this is 2 and 1. So this actually should be 1, but I found 2 with the Aho-Corasick. Is there an oh, I just saw this. Find overlapping iter. That's what we need. Oh, okay, so we just call overlapping. All right. There it is, 54,728. And now we can just blow away all this code. Boom, boom, boom. And I'll just rename these guys. How's that for part 2? A lot simpler. I should write my own, right, and add it to my library. I mean, they're not, it's not a difficult algorithm, it's just fiddly, and I don't want to fiddly it on stream, unfortunately. Tommy says, damn, that's small. Mohad says, what's the purpose of that crate in general? The Aho-Corasick crate is just doing exactly what we were doing, looking for substrings within a string and doing it in a computationally efficient way. So when you have like overlapping stuff, it makes it does the proper thing to start the next search for the next string. It basically builds a trie and then walks a state machine of that trie.